This is probably the last chapter, last topic of this chapter, modeling with the differentiation. Till now, what we've covered with differentiation, that it is gradient. Symbol is m dy by dx, and now we'll introduce a rate into it. A rate that is with respect to time. So let's just build up some basic knowledge. A rate of anything is with respect to the second quantity. For example, if I say rate of change, so rate of change, for example, you have this container and it is filled with liquid up to this red level, and then there is a leak at the bottom. You know that water is coming out at a certain rate, for example 2 centimeter cube per second. So if I tell you the complete volume of this cube, you can tell me the time when it will get empty. For example, this is 3000 cm cube. So we can tell that 3000 by 2, it will take 1500 seconds for the tank to get empty. We can also create different relations between them provided the data is sufficient data is given. For example, let me say this is 6 and this side is 4. So I can ask you the rate of change of height. This is the height. So we know 2 centimeter cube is getting discharged per second. Volume of this container would be, volume is equals to length into breadth into height, and volume discharged is 2 centimeters per second, length is 6, breadth is 4. If I solve for this unknown height, this is 2 by 24 and height is 1 by 12. So I can say 1 by 12 centimeters is discharged per second. The fall in height is 1 by 12 centimeters per second. Any confusion in this part? I can say that dh over dt, rate of change of height, is 1 by 12 centimeters per second. Length is not changing, breadth is not changing, the container will get empty, only the height is reducing. Continuing this, there is a relationship between dy by dx and rate of change. Before I proceed, I would like to share another example. Suppose we talk about the area of the circle. So area of circle is actually pi r square, and consider that this is a paper, black circle and paper, and I drop ink at the center of the paper. This ink will just spread. At start you'll see that it is spreading at a greater pace, then it slows down. So the relationship between the area covered by the spreading of ink and the radius. So I can say dA over dt, that means rate of change of area. I can say dr over dt, that is rate of change of radius. Normally we discuss y is equals to x something, suppose 3x square, and we can find dy by dx. So the relationship between them is dy by dt times dt by dx. See closely, left hand side is equal to right hand side. If you simplify them, dt would cancel out and left hand side is equal to right hand side. For area and radius, the equation would look like dA over dr is equals to rate of change of area times dt over dr. If in question you will ever be given with dt over dr, suppose whatever the value is, definitely when you plug it in here, you will take the reciprocal. left hand side should be equal to right hand side. Let's try a question. This is the example given that the volume of an expanding sphere is related to its radius by the formula volume equals 4 by 3 pi r cube. Find the rate of change of volume with respect to radius at the instant when the radius is 5 centimeters. You can also consider it as an inflating balloon which takes the shape of a sphere. So volume is already given, that is 4 by 3 pi r cube. Find the rate of change of volume. So dV by dt is unknown. With respect to the radius at the instant when the radius is 5 centimeters. Did you get the question? Sorry? Okay. Mad, let me cover the formula first, then I'll come back to this question. Mohammed, we have two things connected. For example, the equation is y is equals to anything, 3x square plus 2x something. So we have y and x connected to each other. So what we can do is we can find the gradient, that is dy by dx. And if someone asks how is y changing, if I change the value of x, y is also changing. If I change the value of y, x is also changing. So dy by dt, we introduced the third variable that with respect to time, if y is changing, suppose the rate is this, and x would be changing at a rate which is this. And equation connecting these three is dy by dx is equals to dy by dt times dt by dx. Left hand side should be equal to right hand side. You don't have to memorize this. Just understand the rate of change of y and x on one side is equal to dy by dx on the other side. Then we have this question given that the volume v cm cube of expanding sphere is related to the radius. Volume and radius are related. If the radius is getting large, what would happen to the volume? What would happen? Sorry? If the radius is getting large, what is happening to the volume? That would increase. So given that the volume, the volume of an expanding sphere is related to radius, formula is given, find the rate of change of volume with respect to radius. When the radius is 5, with respect to radius. So radius is in denominator. It is asking you rate of change of volume with respect to radius. So dv over dr actually. So we have v is equals to 4 by 3 pi r cube. So when we find dv over dr, so this becomes 3 into 4 by 3 pi r square. So 4 pi r square, and we have the value of r as 5. 5 square is 25, 4 times is 100 pi, which is 100 times 3.142, 314.2 centimeter cube per centimeter. Any confusion? Yes, Mohammed. Okay. And which is that? Okay, we can discuss it. Let's just get over with this one first. Second example, a large tank in the shape of cuboid is made from 54 meter square of sheet metal. The tank has a horizontal base and no top. The height of the tank is x meters. The two vertical faces are squares. Okay. Height is x and the remaining vertical faces are squares. So this is x. Show that the volume of the tank is given by this equation. The area of sheet is 54 meters square. Before cutting or using the sheet was like this, whatever the length or breadth is, but the area was 54. If we cut the corners and we'll keep this x, only then we can have the height as x. Are you getting this point? Then we lift up these faces shaded in black, and they join together with these blue lines. They join together to form a cuboid. A large tank in the shape of cuboid is made from 54 meter square of sheet. The tank has a horizontal base and no top. The height of the tank is x meters. The two opposite vertical faces are squares. Show that the volume of the tank is given by this equation. So what would be the volume? Volume is length into breadth into height. Volume of the tank is length into breadth into height. We are very sure about the height and what length and breadth would be. If I say this is the length, would you agree? Question 1. This right here. I said if I say this would be the length, would you agree? Compare these two diagrams. This is a bit neat right here. Okay, we'll discuss it shortly. Let's do it from here. It's labeled. Let the length of the be meters, y meters, and if we had this and if this is y, the total surface area would be 54, which is given in the question, and we have 5 faces. There's no top. If the length is y and this side is x and height is declared already as x, base would be y into x, plus we have 4 vertical sides. One of the vertical side is x square into 2, because we have 2 such faces. Then the remaining side is y into x again into 2, which is equal to 54. Making this formula, and then you make y the subject. Why are we doing that? Because we have to express volume in terms of x. Once you do that, volume is length into breadth into height. Height is already given in the question, which is x. One of the breadth is x and length is y. So you made y the subject of the formula. Yes, Mohammed? Yes. Yx. The top is actually missing. It is an open tank. This right here, no top. That is why we have 5 faces, not 6. So once we write this, we make y the subject. Making y the subject, you then replace it with length into breadth into height, replace y, and it is shown. Second part would say, give that x can vary, use differentiation to find the maximum or minimum value of v. It is given that it can vary. So volume is, what was that? It was 18x minus 2 by 3x square. So dv over dx. So going for differentiation, this is 18 minus 4 by 3x. Whenever it is maximum or minimum, the gradient is 0. So we now solve for x first. 18 into 3 by 4 is equals to x. 2, 9, x is equals to 13.5. 27 by 2 is 13.5. Now we have the value of x when it is either maximum or minimum. How will we check that it is maximum or minimum? That's right. So we already have dv by dx, 18 minus 4 by 3x. So we go for double derivative, d square v over dx square, and we get 4 by 3, which is negative. So d square v over dx square is less than 0. So it is maximum value. Negative means a sad face, so it is a maximum value. So this value of x would actually give you the maximum volume. Justify that value of v you have found is maximum. Okay, this value right here, 13.5. We've checked that it gives maximum value. And let us justify volume is equals to 18x minus 2 by 3x square. So at 13.5, minus 2 by 3, 13.5 squared. This is one of the way, and I'm going to find the value. 18 into 13.5. Something just went wrong with this machine. 18 into 13.5 minus 2 by 3 into 13.5 squared. So it is 121.5. Now I'll check on the right hand side and left hand side. So let me use 14 for this. Minus 2 by 3, 14 squared. So replacing 13.5 with 14, and I'm getting 121.3, which is actually lesser. And then let's try on the left hand side, and I'm using value 13. Let's try. It should be less than 121.5. Only then we'll be able to prove that this is our maximum value. So with 13, it gives 121.3 again. So it is maximum when the value of x is 13.3 and which is 121.5. Other than that, the value is coming down. Yes, sure. Which is that? 3 points in this case, and that is minus 9 comma 12 first, second is 0 comma 0, third is 6 comma 15. These are the three turning points, and we have to sketch the gradient function. So we know we have turning points right on these three vertical lines: section A, section B, section C, section D. If we talk about A, we know the gradient is positive. In section B, the gradient is negative. In section C, gradient is again positive. In D, it is again negative. Any confusion about this positive and negative sign? Now in section A, if I consider this tangent, it will give me some value. And when I move towards right, it is still positive, but it is decreasing towards 0. So if I have to sketch a gradient function, I know that the gradient is actually 0 at x minus 9. So this is minus 9, 0 and positive 6. So at 9 I'm very sure it is 0. Before 9 the gradient is positive but decreasing towards 0. So positive and decreasing to 0. After 9 it is 0 and negative, and the value keeps increasing until it reaches 0 again. Any confusion in this part till now? We are moving from positive to negative gradient. This part, at x9 the gradient is 0. At x9 the gradient is 0. We are sketching the gradient function. And if we look at this part, we are very sure that at minus 9, 0 and 6 the gradient is 0. So we have these three zeros. The graph should touch 0 at these 3 points. And then we are moving from positive to negative. So this value stays negative. Then in section C it is positive, and section D is again negative. So this should be the gradient function. Relate it with the previous graph. Positive, positive, negative, you see it lies in the negative section. Positive, positive, negative, it lies in the negative section. One more thing, y is equals to x4. Whenever you derivate this dy by dx, it actually turns into a cubic graph. When you will derivate it again, d square y over dx square, this will turn into a quadratic graph. If we derivate it third time, fourth time, the degree keeps on decreasing, 24x. Getting the point? In first section there were 3 curves. Power is 4, curves are 3. In second section there are 2 curves. In third section there is 1 curve. In last section there are 0 curves. Linear, that is linear. So this was 2 curves, 3 curves, 1, 2, 3. 3 curves would mean whatever the graph was, it would have a degree of x raised to power 4. So when you derivate it, you will get x raised to power 3, which should give you only 2 curves, 1 and 2. See, any confusion? And we'll always need practice. Okay, what does this say? Sketch the graph y is equal to f of x. On the separate set of x's, sketch the graph of y is equal to f dash x. Let's try this. This is x plus 1 into x minus 4 whole squared. F of x is equals to x plus 1 into x minus 4 whole squared. We have to sketch this graph and f dash x both. So for f dash x, let me first just solve this. Sorry. This is the next question. In question 1 graphs were given. In question 2 he's asking you to sketch and then sketch for the derivative. So if I have to find the derivative, this is first function into differentiation of second plus second function into differentiation of first, which results in 2x plus 2 into x minus 4 plus x minus 4 whole squared and this is 2x squared minus 2 4 times is 8x plus 2x minus 8 plus a square minus 2ab plus b square. So 2 and 1, so 3x square minus 8 is minus 16 plus 2 is minus 14x and these two numbers is plus 8. So we go for midterm breaking. 3x square and 8, 3 8 times is 24, 12 and 2 is 24, minus 12x minus 2x, 3x, x minus 4 minus 2, x minus 4, so 3x minus 2 into x minus 4. So these are basically the two equations. One is this, which is f of x, the other is this, which is derivative. So we have to sketch these two. F of x is equals to x plus 1 into x minus 4 whole square. Chapter 5, we know that x would be equal to minus 1 and x is equals to 4 and x is equal to 4 two times for f of x. And going for the sketch, the turning point is x minus 1 and a positive 4, and we know this is a cubic curve with positive coefficient of x cube. So this is the rough sketch. Box ax cube, remember this, if a is positive this would rise on right and fall on left, and this is cube, there are two curves. So this is your sketch for f of x. And for f dash x, I've used this formula. Y is equals to u dot v dy by dx is first function into differentiation of second plus second function into differentiation of first. One way of doing was this. The other is you multiply the brackets, simplify them first and then differentiate. I'll do it with this method as well. Just let me sketch this. So f dash x is 3x minus 2 into x minus 4, and we can see that x is equals to 4 at the turning point and x is equals to 2 by 3. So this is 2 by 3, this is 4. It intersects at these 2 points, and when we multiply both of these it gives you positive x square. So it is a smiley face, and this is your sketch. and this was your equation, x plus 1 into x minus 4 whole square. X plus 1 into x minus 4 whole square. The second way would be you simplify them first. So x plus 1 into a square minus 2ab plus b square. Then I'm multiplying this. So x cube minus 8x square plus 16x. Then with 1 plus x square minus 8x plus 16 x cube, and solving these two we get minus 7x square. Solving these two we get positive 8x plus 16. Now when you differentiate, so f dash x is equals to 3x square minus 14x plus 8, right? And compare this with the equation right here. Where is the zoom out section? Say that again. Multiplied with the remaining number, that was 1. Compare these two, you get the same answer whatever method you use. This was in this way. I've multiplied with x first, all these three, and then I multiplied with this one with all these three, and you got these 6 expressions, 6 terms.